Okay, guys, let's see how you did on these last 6 problems. So I have the work here for A and B. Let's take a look at them really quickly. I think A was pretty self-explanatory, not too tricky. B was a little trickier because of this radian angle being 4 pi over 9. Okay, so I had to break down the units or the circle or my radian angles. I rewrote pi as 9 pi over 9. Half of that is 4.5 pi over 9. That helped me realize that 4 pi over 9 is actually in quadrant 1. Quadrant 1 angles, the reference angle is just whatever that angle is. Okay. For C, again, 515 was a big angle, so you could have dealt with that if you wanted to rotate more than one time around, or if you want to make it simpler, subtract a multiple of 360. When I did that, I got 155, and it was easy to see 155 was in quadrant 2. And then that blue reference angle in between 155 and 180 is 25 degrees. Remember, from the x-axis, not the y-axis. 7 pi over 6. Really important here. Look how I broke down the angles here, right? 6 pi over 6 is pi. 3 pi over 6 up here is pi over 2. This is the same thing as 3 pi over 2. 12 pi over 6 is the same thing as 2 pi, right? So whatever this denominator is in your angle, it might be helpful to break down the 4 key angles along the edges here, kind of the corners, as what's going on here? Hold on. It might be helpful to break down those angles just so you can see exactly where the angle is going to lie. Okay, so so 6 pi over 6 was here. 6 pi over 6. That's the same as pi, and then half of pi is 3 pi over 6, which is why, remember, 3 pi over 6 reduces to pi over 2. All right, last two. E was 10 pi over 3. That was more than 2 pi, so I subtracted 2 pi to find a coterminal angle. The coterminal angle was 4 pi over 3. That was easier to deal with. That was in quadrant 3, a little bit past pi, not quite 3 pi over 2, right? So remember, I started here. That was pi. I made it 3 pi over 3. Half of that was 1.5. So you can kind of see here, you're going 1.5, another 1.5. Another 1.5 took me to 4 pi over 3. Another 1.5 took me to 6 pi over, that should be over 12. I'm sorry, not over 12, 6 pi over 3, right, which reduces to 2 pi. So when I set that up, it was easy to see 4 pi over 3 was in quadrant 3, and the distance between the x-axis, 3 pi over 3, and 4 pi over 3 is just pi over 3. All right? F, 820 is too big, so I subtracted 360. It was still a big angle, so I subtracted another 360. So remember, you can subtract more than one 360s. You can add more than one 360. Same thing with 2 pi. So when I subtracted two 360s, it got me 100 degrees. That's in quadrant 2. The distance between the terminal side and the x-axis is 80 degrees. All right? So those are reference angles. Good practice. Hopefully those went well. Last skill. Now, the reason we're doing all these skills, we're setting up these trig functions. Okay, you have seen these trig functions before, right? You've seen them in geometry a little bit, and you saw them like this. Okay, now that's okay, but we're gonna have to get a little bit better thinking through those, especially when we think about them on the XY axis. One key thing I want you to start thinking about here, though, is what this function's really doing. It gives you a relationship between sides and angles of a triangle. Okay, so it's really strange because this function takes a theta, and remember, theta is just the variable we use in trig that represents an angle. So this sine and cosine function, the input is an angle. Right, so let's write that down. The input is an angle, right? And the output is really weird, but it's a ratio of sides of a triangle. So these functions are unique. They take an angle in as the input, and they spit out a ratio of sides of some right triangle. That's all they do, okay? So here's what we're looking at now. When we talk about these The ratios, we're going to be using them based on the unit circle. Now, what's nice about that is that unit circle has a radius of 1. Right? We defined that the other day. So look at positive 1, positive 1x, positive 1y, negative 1x, negative 1y. Right? So because the unit circle has a radius of 1, that radius, when you look at our little right triangle here, right, that radius is always the hypotenuse. Remember, circles have infinite radii, right? They go anywhere you want to put them. So because that hypotenuse is always the radius, and the radius is going to be 1, look what happens with our formulas here. Hypotenuse is in the bottom, hypotenuse is in the bottom, right? So the hypotenuse is always 1, which makes our equations a little bit easier. Now look at the cosine ratio, adjacent over hypotenuse. So the adjacent side's down here. That adjacent side corresponds to the x value of whatever this point is right up here. Right? So look, there's a point, right? We'd graph that point x, y. To graph that point, we'd go to the right a certain x value, and we'd go up a certain y value, right? So the x, y values of that point are kind of corresponding with the sides of this triangle. Cosine is adjacent over hypotenuse, so that's x over the hypotenuse of 1. The sine is opposite over hypotenuse, and that opposite side here corresponds with the y value. So when we're talking about the unit circle, and angle is just on the unit circle, the nice thing is, when the hypotenuse is 1, the sine of an angle is just the y value of this red point up here that's on the unit circle. And the x value is just the x value of the cosine value, of theta is just the x value of this point up here on the unit circle. Okay? So again, I just want you to have a general understanding of what these trig functions are. They take in angles and they spit out ratio of sides. If it's on the unit circle, it's nice because the hypotenuse is always the radius, and the radius is going to be 1. So our sine and cosine ratios, the opposite over adjacent and opposite over hypotenuse, and the adjacent over hypotenuse, just turn into y and x. Okay, so the sine value is always going to correspond with the y on the unit circle, the y value of the point, and the cosine is always going to correspond with the x value of that point. Okay, so let me show you what I mean. Let's find the sine and cosine of 90 degrees. So we have to be able to sketch a graph and know that 90 degrees is right here. All right, so there's my rotation, 90 degrees. The point that is on the unit circle here, right there. Remember, the unit circle has a radius of 1. That xy value is 0, 1. That's all you got to be able to do. You got to be able to draw the angle where it's at, and then find the xy value of where that terminal side hits the unit circle. So the cosine of 90 degrees is the x value of that point, 0. The sine of 90 degrees is the y value. All right? So again, it's not going to get crazy right now. I just want you to be able to make angles, find reference angles, find coterminal angles, and be able to identify very simple sine and cosine values. Okay? Let's try this one. 180 degrees. We should be able to draw an angle that starts at the initial side, rotates to 180 degrees, and we should be able to find the xy value of that point there, which is -1, right there, which is -1, 0, right? So the cosine of 180 degrees is that corresponding x value, -1, and the sine of 180 degrees is that corresponding y value, 0. Guys, you can. These values are true. This is how these functions are defined. If you want to go to your calculator and type in cosine of 180 degrees, you'll get -1. If you want to go to the internet, just Google what is the cosine of 180 degrees. You'll get -1. This is how these functions are defined, and it's true always. Okay, let me just show you a few more here. Let's do 270 degrees. We'll just do. Let's just do 270 and 720. We'll call it a day, okay? So 270, that is down here, right? 270 degrees, rotates it from the initial side to here. So the xy value at that point is 0, -1. Guys, these points around the unit circle are just XY values. Remember the origin's right there. Just think about how you would graph that point with radius being 1. So the cosine of 270 degrees is 0, and the sine of 270 degrees is -1. And that's it. Okay, let's do 720. So 720 degrees, it's kind of unique, but that is, one rotation is 360, another full rotation is 720. So 720 degrees is right back to where we started from. The XY value at that point is 1, 0. Okay, so the cosine of 720 is the corresponding x value, 1, and the sine of 720 degrees is the corresponding y value, which is 0. All right. Picture's a little ugly because we did 2 graphs on one. But again, all I want you to be comfortable with today is that these sine and cosine functions, they take the input in as an angle, and what they spit out is a ratio of sides. Now, again, we're not really making the triangles here. We're thinking back to this picture and knowing that on the unit circle, the hypotenuse is always going to be 1, so these denominators are always 1. So the nice thing is that the sine value always corresponds with the y, and the cosine value of an angle always corresponds with the x, because think about what you know about opposite, right? The opposite sides there, the adjacent sides there. So for the trig ratios, sine's always with y and cosine's always with the x. All right. So guys, your assignment for today, there's two things I want you to do. On 32-1, there's a quick feedback activity where you've done this before. You type in the answers. You can check them at the end. For the wrong answers, I put some feedback, giving you a hint about what you did wrong and how to find the correct answer. You can do that feedback activity as more than once. Do it until you get 100%, or until you're happy with the grade. And there's also a short worksheet, 32-1 worksheet. These answers are posted under homework solutions. Be sure to show your work, though. Some of you guys are just trying to show no work and copy down answers. That's not giving you any credit. So make sure to show work, check answers before you submit it. Some of you guys are just doing something and submitting it. I got a few students completely wrong worksheets. I'm not giving you credit for that. Answers are there so you can check and make sure you're doing them right. If you can't figure out one problem, you can email me or stop by the office hours. Okay, guys, have a great weekend. Stop by the office hour if you have any questions, and I will talk to you guys.